Hey guys, today we're going to cover the last part of our review of right triangle trigonometry. So, I don't know if you've noticed, but so far the only type of problems that we've solved using trigonometry have been finding sides of triangles. And of course there's angles in triangles too. Now let me give you a little example of what we're looking at here. Suppose that I have this triangle, and it's a right triangle. We're going to use just a little normal Pythagorean triplet, 3, 4, 5 triangle. Their angle of interest is going to be this angle, and I want to talk a little bit about a notation that you've probably seen before, but maybe don't remember. This is a Greek letter called theta, and it's sometimes used to designate an unknown angle, sometimes used instead of x. And it has to do with how you're measuring that angle, which we'll talk about next week. But in this case, we're going to use theta to stand for this angle. It means we don't know how big it is, but we will be able to solve for it. Now, since this is a marked angle, we can use trig. We could use sine, we could use cosine, we could use tangent, and it would have to use that angle. So let's go ahead and say this is going to be a sine problem. We could say sine of theta. And we know sine is opposite over hypotenuse, so I could start at the angle and go across the middle. There's opposite. And then if I go across the middle from my right angle, I come to my hypotenuse. And this tells us that if I took the sine of this angle, it would give me a value of 3/5. Now I could write that as a decimal and it's a number, but it doesn't really tell me what this angle is. I can put this in parentheses to kind of emphasize this is something I'm doing to this number. You know, sine is a function. It's kind of like taking the square root of 25. You have to do a certain thing to it. The cube root of 8, you have to do a certain thing to it to get an answer. So I have to do a certain thing to this number, how big this angle is, to get this answer. And I can't just like divide by sine. It's telling me instructions. It's an actual operation that I have to do this. Well, all through the year, we've talked about inverse functions as a way to undo things. And as a matter of fact, I just mentioned it. If I had a square root and I wanted to undo it, I would square it because they're inverse functions. So there are inverse functions of our trig function. And I'll just write the notation here so you can see it. I think maybe you've probably seen it before. Sine inverse of theta. This is a separate function. But what it does is these two functions will undo each other because they're inverses. Now I just want to remind you about this notation. This comes from the fact that when we have inverses, we notate them like this. You've seen this before. Remember a whole thing about how if I have a function that's f of x and I want to find its inverse, I switch the x and y and then isolate the y. Well, this is how these values have been derived for sine. There's some other characteristics. You know, I could draw the sine function, draw a line at 45-degree angle through the origin, and they would be reflected over that line. But the characteristic that I'm really interested in is this will undo sine. Okay, what that means is if I do sine inverse of sine, and this notation looks pretty weird. These things, when they undo each other, some people like to say they cancel each other, but that's not exactly accurate. What I'm going to be left with, if I do this function, is just theta. The thing is you can't just do something like square or cube root or whatever on one side of the equal sign. You have to be able to do it on both sides of the equal sign. Now I'm probably asking yourself, what the heck does that mean? How do I know what the sine inverse of 3/5 is? And the answer is it's the same way as you knew what sine of 3/5 was. you're actually going to use your calculator. So if you look at my calculator, here's the sine function. Right above it, the shifted function, you can see sine inverse is right there. So if I want to know sine inverse, I press my second button. I press sine. You can see it's put sine inverse on my display. 3 divided by 5. And it gives me a value. I'm going to round to the tenths place here. So we're going to say theta is equal to 36.9. And this is measured in degrees. It just told me how big my angle is. Okay. Now, I just want to point out that when we're solving this, it's entirely possible that we'll only have two sides and we'll need to find the angle. So when I talk about how do I know what function to use, well, it's going to be the same as we were doing in our other problems. You find the angle that's marked, the angle that you're solving for actually, and then you see which one of these sides are marked. So this is my opposite side, has a measurement. This is my hypotenuse, has a measurement. So it tells me, since I have the opposite and the hypotenuse, that it's going to be 3/5. Okay? So let's just do a couple examples. I got a whole sheet of them here, but you'll get a chance to do some. Okay, right here, here's my angle. I'm going to call it theta for these examples. And I'm going to label my triangle before I do anything. Go across the middle, that's the opposite. Across the middle, that's the hypotenuse. This is the adjacent. The sides that are marked are opposite and hypotenuse. I'm going to put up my handy dandy mnemonic. So, probably getting tired of that. So there's my opposite and hypotenuse telling me to use sine. So it's going to be sine theta, or you could use x, you don't have to use theta. 26 over 43. I'm going to take the sine inverse of both sides. Now, I'm going to tell you honestly, most people skip writing this out on this side. Since we're just reviewing it right now, we're going to go ahead and do it. Give me theta. And into my calculator. So, sure I'm using inverse. I have to press the second button first. 26 divided by 43. 37.2. That's degrees. That's how big that angle is. Okay, let's try this one that's right here underneath there. So here's my marked angle. If I go across the middle, there's the opposite. My right angle, that's my hypotenuse. This is adjacent. You can see my marked sides are adjacent and hypotenuse. Adjacent and hypotenuse. Well, that's going to tell me to use cosine. I'm going to do cosine theta equals adjacent over hypotenuse. I'm going to take the inverse of cosine. So all three of our trig functions have an inverse. Put the parentheses around the theta. You can too. I mean, it's kind of like your choice whether you write it or not. 39 over 59. Oh, 50. Okay, my inverse undoes each other. All that I'm left with is theta. Here's my cosine button right here. There's the inverse right on top, so second cosine. 39 divided by 50. Put it in there, 38.7 degrees. Okay, that's all there is to it. So your work today is going to involve switching between solving for sides, solving for angles, and we'll see how you do. Let me know if you have questions.